Here we start with chapter 8. We're going to be doing a lot of factoring and simplifying and things like that. But before we do that, if you see that in example 1, it says simplify each expression. Under what conditions is the expression undefined? Like what number could I put in there and that denominator would be 0? Because you know you can't divide by 0. Because why can't we divide by 0? Let's think about this for a minute. Because we know that if we have 0 divided by, say, 4, that's 0. Why, if I have 4 divided by 0, why is that not 0? It's divided by, right. Shouldn't you be able to do that backwards? Like if you had 6 divided by 3, that's 2. So you ought to be able to go 2 times 3 is 6. 0 times 4 is 0. But 0 times 0 is not 4. Okay, so if you have to think about it that way, if you have to think backwards about it, then do that. That's why you can't do that. Okay? Okay, so the first thing you really need to do is you need to determine what, even though we don't have an equation yet, if we don't start doing this now, then we're going to not think about it when we start doing equations and when it's really important that you know what y or whatever the variable is cannot be. So the first thing we need to do is we need to factor this if at all possible. So can that thing be factored? I'm rewriting it, so if you want to, if that helps you to kind of, or it helps you to just rewrite the whole problem. This is one of those things, there's going to be lots of ways to do this, and there's not always one exact way to go about these problems. But you do start by looking at the denominator. So if I factor that trinomial there, of course I have y and y. What are my signs going to be? Okay. This tells me it's negative, so they're going to be different. Doesn't matter right now which one's where. Now, I need something that's a product of 6, but a difference of 1. Because there's a 1 right there. So it'll be 3 and 2. Now, since this is negative, this thing right here was negative, where does the 2 go? Plus, okay, because when I add those together, I need the larger number to be with the negative, or when I subtract them. Okay, so now that I have it completely factored, I take each one of those factors and set them equal to 0 and solve for x. We've done that before, so that's not a stretch. Okay. Some of you will still look at it and say, oh, it's 0, negative 2, and 3. That's where it's undefined. Okay. So at whatever point you want to put that, let's see. So this will be 0, right? It's just 0. It's already solved. So y cannot be, we got 0. What's this thing going to be? So when I subtract 2 from both sides, y cannot be 2. And then the other one I have to check it out. So y cannot be those 3 numbers. It cannot be 0, cannot be negative 2, and not 3. Really, you should put those numbers in order. Okay, so that's the first thing. I don't really care what order you do this in. I just don't want you to forget to do the undefined part if it asks you to.
So that's where it asks under what conditions that is.
Yes. Right. But this right here, yeah, you can circle that with an arrow. Yes, that's now we're really simplifying. Okay. But if you go ahead and do that, then you have to factor the denominator, then the denominator is already factored for you. Okay, now. So now I'm going to go through, are there any factors that are exactly the same? Y minus 3. Okay, so y minus 3. So it's not the y that cancels and the minus 3 cancels. It's the whole thing. You have to have completely both of y minus 3. Anything else? Could you simplify before?
Like simplify for y.
These y's. Those you mean? Yes, those y's. So now, and sometimes you start marking out a lot of things, it's hard to see what you have. So let's see, I've got this 4. I don't know what I just did. Oh, crayon. I didn't know crayon was an option. Okay, so I got the 4, I've got this left, and I got this thing left. So you want to get your highlighters out, because sometimes it gets messy. So feel free to do that. So it looks like I'm done. Okay, so let's write what's left. So on top, 4 times y plus 4 in the numerator. Y plus 2. I believe that your book will want you to just keep it factored. Yeah, just keep it in that factor. Like you don't need to distribute through with the 4 in the numerator. Any questions? Okay. Do we want to go ahead and find the part where it's undefined? Where is it undefined? Okay. So can we put those in order? Okay, so that's where it's undefined. And you can always go back and check yourself. Okay, if I put -5 in there, yeah, that makes it 0, the whole thing's 0. If I put a 1 in there, yeah, that makes it 0. Put a 2 in there, yeah, 2 minus 2 is 0. Okay, so you can go back and kind of double check yourself. Did I put the right signs in there? And if you have to, out to the side, if you have to write that out, then write it out. Okay? Do whatever you have to do. Okay. We got any factoring to do? Looks like we do.
Or find it when it's undefined, we always look at the denominator.
Just the denominator. Yeah, because the numerator is not going to matter. It could be anything. Okay, so I'm going to rewrite this thing because this thing looks factorable. But okay, so it starts out with the x squared. So I know my first 2 terms are going to be x and x. This sign tells me they're negative, so it means they're going to be different. Okay, so I'm looking for factors of 8. I'll do this every time. So what are our choices? 1 and 8 and 2 and 4. They give me a difference of 2. Yep, so obviously it's this one. And the sign goes with the larger number. So that's how I can know I know 4 is positive and 2 is negative. And if you really start to struggle, sometimes you're like, I just can't think. Look at your denominator. A lot of times it'll be one of these, just like here. We have the x minus 2 and x minus 2. Usually. Not always. Okay. So now I've rewritten that. So now it looks like we've got everything factored. You can go through and start canceling stuff out. Any questions? I know this doesn't seem too bad. It should be. But it do kind of get messy sometimes. Find everything, gotta get rid of everything. Okay.
On the top, where it says the x equals -1 and 2, is it?
Yeah, should be not, sorry. Yeah, should be the not. X cannot be those 3 numbers. Depending on what is your denominators, how many there are. Now that's all example 2 is asking you. Now why these weren't, I'm just following your book. Now why we didn't have example 1 first. Okay, so here we're just looking at the denominator. So I'm going to factor that. They're always different, aren't they? Doesn't matter. Right, as of right now, we're at the plus and the minus again. What are my choices? Oops, I don't know what I'm going to make there. It's like the 2 and the 5. So, since this is negative, the sign, the negative goes with the larger number. So that way, you need to factor that out to remind yourself What's going on here? What am I thinking? Okay. Now, when you set a factor equal to 0, it has to have a variable in it. Like, we're not going to say x can't be, because you can't, that's obviously not a true statement. Okay? It can't be true. There's nothing we can do there. So you only need to set the factors that have a variable in it to 0. Okay? So we only have 2 here that we could actually set equal to 0. Subtract 2 from each side, add 5 to each side. So again, go and check yourself. Did I get this wrong? If I put a -2 in there, that makes something 0. It makes the whole denominator 0. If I put a 5 in here, 5 minus 5 is 0. It makes the whole thing 0. So then one more step. X cannot be -2 or 5. And that's all that says. Where is it not? Where is it undefined? What can X not be? Now, example 3 is not asking, so you just have to read the instructions. Here we have more than one variable, so we're not. I think the first 2 examples were just leading up to when we have an equation. Of course, we would only have one variable because we just have the X and Y. So we have a Y equal to something. Okay. So it looks like here maybe we can, because you won't always have the trinomial, and that's what you're going to be factoring. Okay, that's not always going to be the case. I look at my numerator. Is there any way that can be factored?
Can't you break up the y squared?
Okay. I'm looking in the numerator, so I'm just looking right here. They have and I don't know how you want to do this. You just want to write it above it, or you just want to rewrite it all? We'll have to start a new line. So if you'll notice that these 2 terms here have a common factor of y. So I'm going to factor that y out, and when I do, I have to look. The y is still there in front. Okay? But inside the parentheses, I write what's left over. Okay? Now, I don't know how you want to do this in steps or if you just, some of you will just say, oh, okay, I know what's happening and I can just rewrite it. Okay? Because you cannot, you can't do this. You can't say, oh, look, let's factor each other out. No, because one's x minus 4 and one's 4 minus x. So any ideas of how I might, they will factor out, but you got to do something.
Multiply it by -1.
How about let's factor them? Because if we can't multiply because we don't have an equation, like to do that to both sides. But maybe from the denominator, factor out a negative. So when this is what's going on. So when you factor out the -1, can we just put it in front there? And then you have -4 plus x. Okay, when I factored out this -1, which I just multiplied by the y squared, it just changes those signs. So you see what happens? So now, that denominator, -y squared, now I have my x minus 4. So some of you can go from here to here. Some of you might need to, I just need to jot that down so I can visually see that.
Wait.
Okay.
So -4 plus x is the same thing as x minus 4.
Yes. And I just switch the signs. I just switch the terms, and their signs stay with them. The sign that's in front of them stays.
Oh, okay.
Okay, so this x right here is positive, so when I write it down, it's still positive. Here it's negative, and when I write it down, it's positive. Any other questions? Not in any hurry to get through this, so I want to, if you have questions, with 6 different types of examples, it's so easy for me to rush it. So if you do have questions, please. Okay, so do you see what's going to happen? You see that these, of course, are gone. Right, if you have to visually see this is what's going on, right? That was what you have left. You have one y in the numerator and you have 2 y's in the denominator. And a negative? Okay. So you can take away one of the y's, and some of you, like you said, you won't need to write that out. You can see this. But I'm just taking a little step further. Okay, so what happens since everything's gone in the numerator? So is that just 0? No, it's 1. Okay? Because think about it. If I put 0, well, it was 0 to begin with. So I have 1 over negative y. You can leave that as your answer. I don't care. Some of you won't like the negative in the denominator. There's nothing wrong with that. It's not like having a radical denominator or a negative exponent. Or you could, if this is acceptable, you can move it out front, or you can move it into the numerator. Either one of them is correct. One's not better than the other. Okay, they're all fine. Okay, but for like EOI purposes, and you come up with this, more than likely this middle choice is probably what your option is going to be. What the correct answer, how it will be written in your choices. Okay, so you need to know that. You need to know that there's one way that you can check it. Okay? Any questions?
So why did it go on negative? Because you switched the forward edge?
Yes. Yeah. Well, right here, I factored out a negative 1. Okay? For this thing right here, I factored out a negative 1 because I can't just factor those out because they're not exactly the same. Because here x is positive, here x is negative. Here 4 is negative, here 4 is positive. So they're complete opposites. So when that comes up, you say, oh, I'll just factor out a negative. So you always factor it out in the denominator. It doesn't matter. And here it really wouldn't have mattered because your answer would have been 1 over y. You still would have gotten the same thing, but we tend to put the variable first. So it would have been completely fine good question to take it out of the numerator. That would have been perfectly fine. Okay. Any other questions? Try the next one. I'll give you a moment with that one. Looks like maybe the same thing might happen. I don't know. Just start factoring and see what happens. Some help factor in the top, in the numerator. Take a look. You need to check yourself. It happened again, didn't it? So we could go ahead if it makes you feel better. When you switch this one, nothing happens. Because I didn't change any signs. You can leave that 5 plus b. But what happens in the second one? Because again, here it happened again. These are not exactly the same. Notice it's positive, negative these are, and the 5s are opposite. So if you can see that, just switch those. Feel free to do that. I just know, okay, when I switch those, and the signs are changing, just throw a negative out front. Okay, so you've got to come over here, and you've got to take this little guy right here and say, okay, I'm going to factor out a negative 1. That changes all the signs, and do that if you have to. So this thing right here is right here. If it makes you feel better to put negative 1 out there, do that. There's nothing wrong with that. That's a B, not a 6. Okay? All of this right here is that and that. Wait, so on the bottom now it's just negative 5 plus b. Right, that was this thing right here. I factored out a negative. That right there is that right there. This didn't change. I just swapped them.
Oh, so you don't have to factor that side too? Like you just factored the b minus 5?
Right. Because the 5 plus b, the signs didn't change. The signs are the same. details, huh?
Wait. So how could you do it to the b minus 5 if you didn't do it to the b plus 5?
Because I didn't need to do it to the b plus 5. Because the b's are still positive and the 5's are still positive. Signs didn't change. Only when you need to change the signs. Okay. Okay, so I just underlined so you could see what was what. These were go together. This I came out here. You need to see that. Okay. So now we have, it looks like all it's going to factors are b minus 5. All of that and only the b minus 5 factors. So the negative 5 plus 3.
It's the same thing as B minus 5.
Mm-hmm. Okay, so what's left? That's our answer. You can just leave that negative out front. That's perfectly fine. You don't need to multiply that back through. Okay. Again, just like down here, if you're on a standardized test, it's probably going to be more like this. The negative's probably going to be out front. Out the middle there. Okay, any questions? Okay. Okay, so now we just have two fractions we're going to multiply together, and they have these little binomial terms. Monomial. Again, lots of different ways that you can do this. It can get kind of messy. Okay, so I don't know. I just start crossing stuff out. Okay, that's what I do. Like for instance, do you see? I mean, if you want to write it all in one line, I just think that's not necessarily necessary. So do you want to start with the numbers or with the variables? The variables. Okay. So really, I mean, they're all. You would make that one big fraction if you wanted to. You could multiply everything together, but then sometimes it's harder to see some of the factors. Like, for instance, I know you said you wanted to do variables first, but like I see that 21 and 14 both have a factor of 7. That's a lot more noticeable in here than if I multiply the 12 and the 14 together. And I multiply the 21 and the 8 together. Okay, so I could go ahead and simplify things. And that would be 3, and that would be 2. Okay. Doesn't matter where you start.
So you have to,
Can we do the 12 and the 8?
right around
Yes. You see that 12 and 8 have a common factor of 4. Look what happened. Look what actually happened. Actually, I would multiply those numbers together. Well, no. Just trying to think why they all. Oh, because I keep seeing this as 2 and not 21. Okay, so you see now 3's cancel and the 2's cancel. Actually, they're not, but we are left without any numbers. You see those 2's cancel each other out and then these 3's cancel each other out. So if you want, okay, this is getting messy, so maybe go ahead and write down what we have left. Don't have to be in any particular order. You could do that. I mean, it's kind of up to you. Now we can start looking at the variable parts of it. What happens here with the a and the a squared?
There's only one a left.
Right. So think about that. Remember, this is a 1. So if I have 2 a's in my numerator and 1 on my on the denominator, then that just leaves me with an a in my numerator. How about c's? Same thing happens. I have 2 c's in the bottom. So think of it as 3 minus 2. That leaves you with just a single c in the numerator. And then the d, same thing happens. There's 1 down here. 2 minus 1. And then your d's are gone. So yes, you probably want to write that in alpha order. Just kind of, your final answer is A, C, D. Denominator was totally gone. totally factors, simplifies. Yeah, but anything over 1 is just itself, so. There is a 1, good point. There is a 1 in the denominator. Okay, but that's different than if there's a 1 left in the numerator. Because we know, like if it was 4 over 1, of course 4 divided by 1 is just 4. So same thing here. But if you did 1 over 4, we know we can't just not write something in the numerator. So that's a good point. So be sure that you're aware of that. Any questions? Okay, try the next one. I'm kind of just regrouping here and see what all I have. I think it gets messy when you start crossing out a lot of stuff. It's just kind of up to you. Like I said, there's not just one little simple formula of how to do this. Before I start, you know, you want to get some colored pencils out, and that might help you. Feel free to do that. And sometimes you get to the bottom, you're like, oops, I didn't get everything. Oops, I forgot to cancel that out. Got everything. They always tell you, oh, you can always check yourself. Yeah, well, it's not an equation, it's hard to check yourself. So don't get in a hurry. It's like any other math problem. Don't get in a hurry. Take your time. Real easy to make a mistake. Yes.
Where did your 3 go for the 18?
Right here. 5 times 3.
Oh,
Any questions? Get it cleared up. Yes.
How'd you end up with the 18 final answer?
Because 5 times 3 is
Oh,
15.
okay.
It didn't simplify with the 7. Any other questions? I know there's lots to take in. Not hard, but simple details of this that make it hard. Any other questions? Okay, we have some division ones coming up. Oh yeah. What happens when we divide? My notes of division. April, other change. Now we just flip the second fraction. So now it's multiplication. So just invert, multiply. Here's the first fraction, multiply by the second one. And you have to invert it. And then we'll do what we were just doing. Regroup here. I don't put any when I'm kind of regrouping here. I don't try to put my variables in any kind of order. I just go ahead and multiply my numbers together, my coefficients, and then I just saw mt squared and I saw a squared and b squared, so that's what I wrote down. Went ahead and multiplied my coefficients here, and then just wrote what variables were still there. So if you could just look at this right here and just mark away, and that's fine if you want to do it that way. I don't have a problem with that. but it's just really easy to overlook stuff. But then if you do this, I could write something down wrong too. It's just kind of a matter of what you prefer. What is it? Anything? Careful behind. No way to go back and check yourself, so then just do the problem again.
Wait, so is it rid of the 24?
Why did I do what second?
Why did you get rid of the 24 and your silver second? Square.
Okay, so I rewrote this,
Oh,
and the 21 and the 7 had a common factor of 7. Is that what you mean?
oh, okay.
And the 16 and the 24 had a common factor of 8.
Okay. I just missed that.
It's okay. Thank you, I get it. Have you flipped your second fraction? Are we already on the next problem? Now we're multiplying and inverting my second fraction. Every time it's the second one. Okay. And some of y'all might have noticed, I could have went ahead and factored the x out right there. I could have simplified the 16 and the 6. I mean, I just saw that 6, this 12 had that factor, or that same factor of 6. So that did that was totally gone. We might have done it a little bit differently. You're multiplying everything, so the order's not going to matter. So that part makes it hard. It really, really does. Maybe I should have went ahead and factored this down right here. That way, that
So, what's like x4 times x2? You add them.
x2 times 2, we're multiplying.
So,
Some of y'all may not want to try to follow me. You might just say, okay, I got this. Hopefully my school starts. Any questions? Green one. Next. Okay. So now it looks like we just, like the previous problems we were doing, we had just the monomials. Okay, so now we've got some binomials, and we have some trinomials, and we've got to try to factor all that stuff out. So I'm going to go ahead and instead, I'm just going to rewrite the whole thing. So I'm going to take this thing right here. What do they have a common factor of? 4. I'm going to factor the 4 out. Okay, and there you can do a quick check. If I just read that back through, would I get 8x minus 20? Would I? As far as you can't plug it back in. Okay. Now I'm going to factor the denominator. Not a lot of choices for 35, is there? Again, signs are different. And we don't have any where the signs are the same. Oh, we're going 7. So obviously 7 and 5, since this is plus, the plus goes with the larger number. If it was negative, the 7 would be negative. Any questions? Okay, so we're just factoring away on it. Good. Now I can already see this is going to happen, but you have several things that happen here because you take out the 4, and then you have the difference of squares right there. Okay, remember that? So this I actually have 4 times x plus 2 times x minus 2. This thing right here factors into that. Any questions before I go? Let me make this perfectly clear. And people will do this every time, and I'll say it a billion times not to do it. This does not cancel with that. It has to be a factor in order for it to cancel. X squareds are not factors. They're a term of this. This thing factors to this. Okay, so don't try to do it. It's never going to work. Never has worked. Never will work. Okay, so don't think, oh well, it's okay. I can do this. I know people always do it. I don't understand. Any questions or anything that I've done? Now you can start factoring. If you haven't already. Just leaves a factor. Once I factored everything out, you see that it's the whole x minus 5. These things were factors, so they cancel each other out. The x minus 2s are both factors, so the 4s were factors, so they cancel each other out. And you don't have to multiply anything back together. Just whatever's left over, write it down. Numerator in the numerator, whatever's left over the denominator, whatever's in the denominator. Any questions? Fine. I don't call that, so. Okay. And I think when I rewrite this thing, I'm just going to flip it. You know what I mean? Like I'm just going to go ahead. I just try to write as least as possible. Is what I try to write because it can get messy and confusing. And I guess I'll go ahead and finish this one out. I'm actually, since this thing is division and I got to change it to multiplication, I'm just flipping it as I rewrite it. when you're trying to factor that on your own and you're not just writing down what I wrote, you see that I flipped the second fraction. We are dividing, so we have to invert it and multiply. The x plus 3's are both in the denominator. They do not cancel each other out. So don't try to do that. Okay. Any questions at this point?
We just write x plus 3 and square.
Yes, that's what I was going to say next. So this answer is fine. Okay, but when you're doing any kind of, whether it's ACT or if you're doing EOI, probably the way you're going to see the answer, since there's two x plus 3's, it's probably going to be x plus 3 squared. Okay, just like you get two y's. What's times y? You know, that's y squared. Okay, so you need to know that. Any questions? Okay, well, again, you could see a division problem like this. Okay, it's the denominator that you would invert. So this is what we're dividing. So 8 times 4x minus 10 all over x squared minus 4. That's how you would rewrite it. Okay, so again, you want to invert the second fraction or the one that's in the denominator. And I'm going to factor again. Now, if you feel better writing that out twice, that's fine. Probably for most of you, that might be a good idea. See if that thing factors. Signs are the same. This tells me they're the same. And I'll look at the middle term and it tells you what two signs they are. Again, this thing right here, it's the difference of squares. Forget that. Spin a little bit. You do all of that, and what happens? Well, I guess two things factor. You get rid of the 2's, but then the only other thing else that factors out is an x minus 2. All that work, and that's all you get out of that. Order doesn't matter. Doesn't matter if you write the x minus 2 first or the 2x minus 5. You're multiplying. It doesn't matter. Just writing it in the order that I see it, and then writing in the denominator. Again, you can't say, oh look, there's x's. Those cancel. No, they're not factors. No, they don't. Any questions? Okay, I think some of you already started on the next one. So go ahead and rewrite it. Oh, look what happens. You see it happens again? I'm going to go ahead and factor out that negative. So I'm going to write negative, because there's a negative 1 right there, x minus y. Oops. How about, oh wait, I wrote it right, didn't I? I'm trying to hurry, because I know our time's about over. Yeah, x minus y.
Wait, why did you know to do that?
Well, because I can see that here I have an x minus y, and that's, I just can see what's going to happen. If you don't do it then, you're going to want to do it later. Okay? Now I'm going to factor all this stuff out. I just rewrote that. Okay, I just wrote the y plus 7 on top, the numerator, and now the numerator is the denominator. And so to be able to switch them, and there still be a negative in between them, you have to factor out the negative. Give me one more second, I'm almost done. If you get this. Oops, I'm trying to flip it again. I already flipped it once. See, that's why you don't get it hungry. Don't go ahead and leave your food. Try to figure out the rest from there. Now, if it makes you feel better to go ahead and put parentheses around that, you might want to do that. Okay. Again, all I have left is these two things, and there's going to be a negative out front. That -1 right there. Yeah. Oh, so three. Yeah. From this -1 right here. Throw it out front.